Welcome to the build video for WeighMyBru. In this video, we will be building the DIY scale from start to finish. Here you can see some of the hardware required. A full bill of materials can be found in the link below. Let's start by placing the heatset inserts into the 3D printed housing. The insert set here came with a tool to use with your soldering iron, but this is not necessary. You can just use the tip of the soldering iron. These heatset inserts are 3x5x4. Here you can see the tool on the soldering iron. The heat from the soldering iron will heat up the brass tool and the heat will transfer it into the insert. Ideally you want to use a jig that will press the insert in nice and straight, but it is not essential. Just make sure the insert goes in straight, as the lodesol will be fastened onto these inserts. Apply a consistent pressure while keeping the insert straight. Follow the same process on the second insert. If the insert is not straight, you can always apply heat again to the insert, and then move it as necessary to get it straight. Next we will insert the power switch into the housing. Depending on how well calibrated your printer is, it may be necessary to cut away some plastic if the switch does not fit. The housing is designed for it to be a tight fit, so be careful not to cut too much away. If the switch is a loose fit, you can always use some glue to hold it in place. Place the switch in the housing and give it a firm press while being careful not to damage it. The switch should slide into position. Give the switch a test once it's fitted to ensure it is switching properly. It is advisable to buy components that do not have the header pins soldered on. However, if you get parts that already have the header pins soldered, then they can easily be removed. Start by using a pair of side cutters to cut the pins off. I like to cut them off right up against the black plastic spacers. Once all the pins have been cut off, use the side cutters to lift off the plastic spacers. Place the side cutters between the board and the spacer and slowly squeeze them closed. This will force the spacer upwards. Be careful not to cut the remaining piece of pin off, as you will need to pull on this piece when removing. Use your soldering iron to apply a small bit of solder to each pin. This basically reflows the solder and makes it easier to remove the pin. Use your side cutters or a pair of pliers to grip the first pin. Hold the pliers with one hand while applying a small amount of pressure on the board against the table. With the other hand, use the soldering iron to heat the solder on the pin. As the solder melts, the pin will become loose, pull through the board, and be out. Continue the process on all the pins that need to be removed. With all of our components depinned, we can now start assembling them into the housing. Start by placing the touch pads into the housing and fastening them with the small 1.7x4 self-tapping screws. There are 4 mounting holes in each touchpad, but it is not necessary to use all of them. I recommend using 2 screws per touchpad, placing them diagonally opposite each other. Once the touchpad has been fastened in place, ensure it is tight. Carry out this same process on the second touchpad. Next, we will place the display into the housing. This component uses a small bracket to hold it in place, as it does not have any mounting holes. Ensure the terminals are facing the right side of the housing. The bigger of the 2 brackets is used for holding the screen in place. Use some 1.7x4 screws to fasten the screen bracket in place. Check that the screen is fitting correctly. The screen should be a good fit without the need to adjust. If it is necessary to adjust, loosen the bracket and make the adjustments necessary. Next, we will mount the HX711 to the housing. Ensure the load cell connections are facing the bottom of the housing. Ensure the power, communication connections are facing towards the top of the housing. The mounting holes on the HX711 are bigger than the screw heads, so it is necessary to use some small washers to ensure the screws hold the board to the housing. I have provided some small M2 washers that can be 3D printed. Similar to the touch pads, there are 4 mounting holes on the HX711, but it is only necessary to use 2 screws to mount the board to the housing. Once the board has been mounted, ensure it is secure and will not move around. Next, we will fit the ESP32 into the housing. Angle the board slightly and place the end of the USB-C port into the cutout. Once the port is sticking through the hole correctly, the board will lie flat into the housing. Take the remaining 3D printed ESP32 clamp and fasten it into place using M1.7x6 self-tapping screws. This will secure the ESP32 board to the housing. Next, we will fit the load cell into the housing. Always be careful when handling the load cell. This is a 500-gram load cell and can be damaged if too much force is applied to them. One side of the load cell has untapped holes. Use these holes to mount the load cell to heatset inserts. Ensure the text is upside down and the wires are positioned on the right-hand side of the housing. Use M3x12 button head screws to fasten the load cell in place. It is important to use button head screws, as standard cap screws will be too large and possibly cause mechanical interference when mounting the 3D printed bottom plate. Before tightening the button head screws, make sure that the load cell is straight. If this is mounted skew, the bottom plate will not fit correctly. Next, we will begin to prepare some cables that will be used for power and signals between the electronic components. I am using a piece of Cat5e Ethernet cable and stripping the inner cores from the cable. Use a knife to cut through the outer insulation. Flex and bend the cable to break through the insulation. Slide the cut piece off to expose the inner cores. Be careful not to cut yourself when using the knife. Once you have removed the outer insulation, you will need to untwist the individual cores. I use a piece of the insulation to assist with this process. Once the 2 wires have been untwisted using the piece of insulation, squeeze the insulation onto the wire and pull. This will help straighten the wire. Your wires are now ready to be used. Next, we will start preparing the components that are used in the battery monitoring circuit. This is a simple voltage divider circuit using 2 100 kilo-ohm resistors at 1% tolerance. We will start by soldering the 2 resistors onto the JST connector. 1 resistor onto each leg of the connector. Cut the legs of the resistors to the same length as the legs on the JST connector. Use some 22 or 24 AWG wires to connect the JST connector to the ESP32 board. Strip back a small portion of the insulation so they can be soldered to the connector. I like to use a small piece of press stick, sometimes called blue tack or sticky tack. This helps me hold wire or components in place while soldering. The process of applying solder to a component or wire is sometimes called tinning. The process of tinning each component before trying to solder them together makes it much easier. It is important to ensure we get the polarity correct when soldering the connections. I like to take the JST connector and loosely plug it into the battery. This way I can see which leg will be positive and which leg will be negative. In this build, I will be using brown colored wire for the 3.3 volt connections and blue wire for the 0 volt connections. Here we will solder the resistors to the JST connector. Next, we will solder our wires onto the JST connector in parallel with the resistors. This can be a little tricky, because when applying heat to the wire, the resistor can sometimes come loose. Try not to apply more heat than what is needed when carrying out this process. Next, we will use a small piece of heat shrink to insulate the resistors and wires where they solder to the JST connector. The other ends of the resistors will be soldered together and connected to the ESP32 board. It will be necessary to remove the clamp holding the ESP32 board in place, as we will need to solder wires to the GPIO pins. We will need to remove the board to access the battery solder pads underneath the board. We will also need to solder some wires to the power switch. In this video I am using the brown wire for the positive connection and the blue wire for the negative connection. The black wire is the voltage reference wire that will be connected to the GPIO pin. In this step I will apply some solder to the necessary pads that will have wires connected to them. Next, I place the ESP board into the housing to check the length of the wires required for the power switch and battery. I like to run the wires underneath the ESP board just to try keep it looking neat. It is important to check the angle of the wires when soldering them for the battery. Ensure they do not crash into the raised part of the housing, otherwise the ESP board will not fit correctly. We will use the power switch to break the negative wire of the battery feeding to the ESP board. Once you have the correct length of wires, solder them to the power switch legs. You can use either of the outer legs and the middle leg. Once everything relating to the battery wiring has been soldered, I like to plug in the battery and test that the switch is working and the ESP board is powering on. Now we can start to connect the power wires for the other components of the scale. Again, I will be using brown wires for the 3.3 volt connections and blue wires for the 0 volt connections. I like to feed the wire below the power switch. This is just to try keep the wiring neat. Solder the blue wire onto the ESP board pin labeled G and D. The inside walls of the housing has channels that can be used to help route the wires to their next location. In this case, we are daisy chaining all the power connections of the various components in this scale. Use a small flat screwdriver to help guide the wires into the channels. We will do the same with the brown wire for the 3.3 volts. The next component to supply power to will be one of the touch pads. Measure and cut the wire to the necessary length. Use some press stick to hold the wire in place. This is necessary because all of the connections for power will have two wires soldered to them. Prepare the second wire for soldering to the same pad. Once both wires have been soldered to one pad, ensure that both wires have a good solder connection. This is the process we will use when soldering all the power connections with two wires on one pad. Here you can see the load cell has been removed, as well as the clamp that holds the display in place. This makes it easier to solder the wires and route them where they need to go. Now we will follow the same steps when connecting the brown wires to 3.3 volts, just as we did for the blue wires. Once again, we will connect the battery to test that there is power to the individual components. Note, the screen will not show anything until the ESP has been programmed. Next, we will start with the DAD and CLK connections for the HX711. Next, we will start to connect the wires for the touchpads. These can be done in any order. The wire routing shown in this video is not the only way for it to be done. This is just a guide on one of the ways that is possible. Next, we will connect the wires for the display. Here we see a close shot of the wiring we have completed so far. Next, we can put back the display mounting bracket so that it holds the display firmly in place. Now let's put the load cell back into the housing and ensure it is straight when tightening it down. Next, we can put back the clamp that holds the ESP32 in place. Be careful not to clamp the wires too tight. The last wires to solder are the load cell connections. The color of these wires corresponds with the markings on the HX711 board. I like to route the load cell cable under the corner of the display mounting clamp. Ensure there is not too much tension on these cables as it will affect the readings from the load cell. Lastly, we will connect the battery via the JST plug. I like to use a small piece of VHB tape or double-sided sticky tape to hold the battery in place. Let's take one final look at the completed scale. Once you are ready, flick the power switch and watch the scale come to life. Once you are happy that the scale is functioning correctly, it's time to close up. Use two M3x12 button head screws and fasten the bottom printed piece to the load cell. Ensure there is an even gap all the way around the housing. Congratulations! You have just completed the assembly process of the WeighMyBru scale.
Just joking, you are not actually complete yet.
As an optional extra, you can add some non-slip rubber feet to the bottom of the scale. If the scale is going to be used with an espresso machine, I recommend taking the drip tray from the machine and placing onto the bottom of the scale. Take a marker or a pencil and mark 4 of the holes nearest to the 4 corners of the scale. This is where you will place the rubber feet. It will ensure the scale sits in the correct position in relation to the drip tray. These rubber feet have an adhesive on one side already. Peel them off one by one and place them over the holes you have marked in the corners. Ha ha ha! Now you are done. Go and make yourself a well-deserved cup of coffee.